Hello everyone and welcome to day 4 of the 2024 Advent of Code. Just going to jump straight into this today. I'm going to be using Python and the idea is that we have this word search and we need to find the word XMAS and that can be either horizontal, it can be vertical or on either of the diagonals. And for this one I'm going to show you how I've done it. It might not be the fastest way or the most efficient way, but I think it does part 1 and 2 in less than sort of half a second, and I think it's quite easy to read, which is one of the main things that I want from this. So I have here the data and the example data, and if I just print out line by line, you can see this is kind of what it looks like. And what I want to make is this word search string, which I'm going to use to house all the letters in the word search. And then I'm gonna get them. I've decided to do this rather than an array of array or a list of lists. It's completely up to you, but I'll show you why I think it's quite nice later on. So the first thing I want to do is to strip the end space, which I believe will get rid of the new line characters. And then I want to say for each of them, we'll just add them to the word search. Something like that. There we go. And if I was to print out the word search, which I just seen I've spelled it wrong, word search, we should get the whole thing in one big string. Great. So it can be useful to also have the height and width of the word search. So we've got the height. For later on, if I could spell, for later on, which we can calculate here. So we know each of these lines is the width of the word search, and then the total length of this line of this string that we have here divided by that is the height. So if I just make that now, so the width is going to be the length of this, and then the height is going to be the total length divided by the width. I believe if I just did this, I'd get something like 1.0 or 2.0 as a double, so or as a float. So that should work. And if I was to print those things out, I should get the things that I want. Yep, the 10 by 10. And then all we're going to do quite simply is to loop over the whole thing and look for these words. Now, I think the best way to do this is to search in the Y direction and then in the X direction. So if we look for or Y in the range up to the height, and similarly we look for X to the width, then we can get all the words, so the words in all directions. And I should say my strategy here is to find all of the X's. So here, this is the first letter that we're looking for, and then look north, south, east and west, but then also in each of the diagonals. And then if any of those are XMAS, then we found one. Because then we will know that this is the first one, and then we got M, say this was A, say this was S. And so what we can do is we can make this list, and then we can say that the found word counter would be this list. Oops. Yeah, would be the words, word for word in this list if the word is equal to XMAS. That's going to be the general strategy here, and then at the end of it we're just going to print this found word counter, and I think just to make it accessible, I just need to pop it there. So we're just going to add on the length of this. For example, we could find that XMAS starting on this current X is one going up and then one going to the right as well, which would be both. And what we need to do is we're only going to look for X's, these capital X's, so we can say, okay, at this place, so if something like get letter at X and Y is not equal to X, then we can just continue to the next letter. Continue. And I like building up the code like this, the structure like this, without necessarily filling in all the implementation details and just kind of doing them later. So here we have this get letter at, which I'm going to implement later. And also for the words in all directions, I want something like get the word north for X and Y. And then I want, all the way down to say get word for the south. Let's say if we're moving around, it would be around the clock would be west, X and Y. And then also we'd want all the diagonal ones as well. So, say if we were starting in the top right, so get word north, east, and then going all the way around to the northwest, if we imagine going like around the clock. And I think what would be best for this video is if I show like an implementation of just one of these, and then I will quickly fill out the rest. And then, you can have a look at them and see how they're done, but they're all done very similarly. And then I can show you from there. And then this get letter at method as well we need to make. So firstly, I'll make this get letter at method. So we're going to give an X and a Y, because we've not stored the word search in a 2D array. We need to somehow translate X and Y into being this. And you may have come across this before, but the one way you can do this is by taking the words, or taking those two things and making an index out of it. And you'd take the X component, add to the Y component, and add the width of the width of the word search many Y components. So if you can imagine, as X is going up one at a time, so we're going to go along one, but for every Y we want to jump down to the next one, which is like adding 10, so we could be on 0 here, or 10 here, or 20. So moving down is the same as moving along 10, and that's all this is saying. So we'll get this index, and then we can return the word search letter at that index. But also there's a couple of checks. We also want to make sure that X and Y are not out of the boundaries of the word search, that are not off to these sides. And that's why it was useful to hang on to these. So we want to say if X is less than 0, because we know we can't have that, that would be off to the left of the word search, or Y is less than 0. So that would be, because we're counting Y downwards, that would be off to the top. Or if X was greater than the word search width minus 1, because if it was the word search width, remember we count from 0, that would be 10. So the word search width is 10. It would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 would be here, where actually 10 is the one underneath. And for a similar idea, if Y is greater than the word search height minus 1. If any of those happen, we're going to say there's nothing here. But if that's not the case, then we're going to return this word search index. That's going to get us that. And then I'm just going to implement one of these, and then I will copy all the rest in. So let's say we want to just implement this one, which is to get the word that starts at the letter that we're on now, which is an X, starting at XY, going north. So say for this M, it would be M, M, S, M. That would be the word. And we want to get that. And if we were to, example, have this S, S, M, S, nothing, that's what we want to return, you know, those. So we're going to give it X and Y. And we're actually going to do it as an array, and I'll show you for Y just now. So we've got letters. We want to get the letter at X, Y. And if you think we're going to have 4 letters here, so 2, 3, and we're going north, which means that we want to change the Y component, and Y is going to be increasing as we go down, decreasing as we go up. And so that means that we want Y decreasing. So -1, -2, and -3. And then we've got these letters like that. And then we want to return these letters. But what we actually would like is, rather than this array, we could make a new function called something like array to words. And I will define that here. This will take the array. And all that will do, it will join them all up. And a nice way to, well, I want to join them up when they're not none. So I just want to join up the ones that are in the word search. Just say for this example, I'll have S, M, S, none. I just want the word SMS to come back. And one way you can do this is by taking an empty string, joining these things into the empty string. So you can say A or letter or anything like that. So letter for letter in the array if the letter is not none. And that will give me those SMS rather than SMS none. And it will allow me to return that as a string. So we've got one of the words, that's the north word. Then we'll need the east word, the south word, the west word, and then the one at the northeast, southeast, northwest, southwest and northwest. And then we can evaluate all them. So I'm just going to add them in now. And here, as you can see, I have all of those functions. And if I just peek into one of them, we've got the same thing as we've got for the north, but all we've done is changing these indices. So for going northeast, north, meaning that the Y component is going to be decreasing, and east, the X component is going to be increasing. So you can see that here. And it's the same for the other ones here. So I have all of them, and now I want to have I want to populate the rest of this list. So if I go like this, and I'll have the east, I'll have the one to the south, and then we've got this one to the west. Then we want to get the word northeast. Is that get word northeast? Oh, there's no comma. And then we want to also get north. If we were going around, we would go southeast, southwest, southwest, and then northwest. So now we have all these words, which are, they could be one letter. It could just be, say, this X. Could be 2 letters, 3 letters, 4 letters. In all the directions, these are all the possible words, starting with an X. and then we're going to go through those words and see if any of them are XMAS. If they are, count how many they are, and then go there. And if I was to print this found word count, we get 18. Oh, yeah, we get the width and height again in 18. And if we look here, that's exactly what we expect. And so if we were to run that on the real data, we get 2642, which is the answer here. Now for part 2, it's really similar actually. It's on the same word search, but instead of looking for one word like this, XMAS, what we want is we want a cross mass. So we want to see something like MAS in one diagonal and MAS in another diagonal. So these diagonals could be either way. So you could imagine swapping this S and this M, or swapping this S and this M. We just want an M and an S on the two opposite corners of an A. And when we put it like that, it's quite similar to part 1 actually. So if I was to take, if I was to label this part 1, part 2 is not too dissimilar. So if we take this first bit, we want to say we want to get the letter in the four corners. So if I was to say get letter at, we want the one to the east. Sorry, not to the east. We want to the northeast. So if I was to do that, and I'm gonna pair them up actually on opposite diagonals. So this would be northeast and southwest. So south being increasing y and west being decreasing x. Try and keep that neat. And then these two are going to be northwest and southeast. So north being decreasing y, west being decreasing x, and then south being increasing y, east being increasing x. And oh yeah, we're checking on A's. So if it's not an A, continue. If it is an A, get these letters in the opposite corners. And then we essentially want to say, if the northeast, if this one is an M, and this one is an S, or this one is an S, this one is an M, and similarly here, then we found what we want. We found this X cross. And one way to do this, we could do those 4 checks, you know, MS, SM, MS, SM, you know, so one of them and one of them. A nice way to do this would be to take the set of these and see if it's the same as the set, this set, S, and the same for this. So we're going to call this letter, this was east, northeast, so letter northeast, and this was letter southwest. If we were to say the set of these two, if it was equal to this thing, that's 1/2 of what we want, if that. And also if these two were this set as well, right? So if this was M, this was S, or this was S, this was M, then we'd have exactly what we want. So if I just name them, so this was northwest, yeah, northwest, and this was, oh wait, sorry, this one's northwest, this one's southeast, and same as this, if we wanted the southeast and the northwest ones to look like that, then we want to increase a counter. Let's call this the cross mass counter. We want to just increase that because we're only finding one here. You know, one finding is where we have the A in the middle, and then we have like mass, or in any of these configurations. We'll go through all of them, and then we'll print that. And if we were to run that on the example, we would get 9, which is what we're told here. And if we were to run that on the actual data, we'd get 1974, which is what we'd expect here. So hopefully you like this approach, where I just did a little bit of the implementation and then showed what the other ones would look like. I think it would be a bit tedious if I was drawing all these out, writing all these out. Hope you enjoyed. If you did, please leave a like, comment, and I'll be back for day 5.